Welcome to The Explainer. I am absolutely thrilled to have you here today because we are charting a course to true exam mastery for Cambridge Computer Science. Whether you're studying under syllabus code 0417, 0478, 2210, or 9618, you are in the exact right place. Today, we're unpacking the real mechanics of hexadecimal representation. But listen, we aren't just going to sit here and read textbook definitions at you. No way. Think of me as your strategist, your astronomer, if you will. We are going to navigate by the stars, and in this universe, those stars are the key command words on your exam paper. We're going to use them to chart your course directly to top marks. So let's dive right into this. Picture this scenario for a second. You walk into the exam hall, you sit down, you open your past paper, and you see a big question on hexadecimal. Instantly you think, awesome, I know this. You write your heart out. But weeks later, when the results come back, the marks just aren't there. It's incredibly frustrating, right? Well, we are going to fix that completely today by building a rock-solid strategy that guarantees the knowledge in your head translates perfectly onto the page.
And this brings us to a really crucial question. Why do so many smart, capable students lose marks on topics they genuinely think they know inside and out? To answer that, let's look at two typical computer science students. We'll call them Alex and Sam. Now, Alex is what I like to call our walking encyclopedia. Alex knows every single fact there is to know. When a question pops up, Alex overloads every answer with raw computer science facts, practically spilling everything they've ever memorized onto the page. But here's the catch. There's absolutely no analysis. It's just a giant data dump. Then on the other end of the spectrum, we have Sam. Sam is a rusher. Sam looks at the clock, starts sweating, and races through the paper. In that panic, Sam completely misses the command word requirements. Both of these students walk into the exam hall feeling totally prepared. But both of them are going to lose points because they misunderstand what the examiner actually wants from them. They see familiar vocabulary, and their brains just go on autopilot. If you were to look at their answers side by side, you'd see Alex with a massive, unstructured sea of text, and Sam with just two hurried, vague bullet points. And unfortunately, both of their papers are absolutely covered in red pen marks from the examiner.
And those red pen marks brilliantly illustrate what I call the ultimate trap, recognizing a word, but answering the totally wrong question. Memorizing an isolated definition is actually super dangerous in these exams. Let's break down exactly what happened. Alex saw the word hexadecimal on the paper and instantly, without thinking, wrote down base 16 number system using 0 to 9 and A to F. Now, is that statement true? Yes, absolutely. But it's completely useless if the question actually asked why a programmer would choose to use hexadecimal for a memory dump. Alex spotted a familiar term and completely missed the context of the question. Those red pen marks are a direct result of not analyzing the precise assessment objectives. You simply cannot just retrieve a fact from your memory and expect full marks. You must actively shape that fact to fit the specific demand of the question.
Section 1. Beyond the vocabulary list. This is where we move past rote memorization. To secure those top grades, we must establish the foundational why of our topic and build a robust, foolproof strategy to tackle any question. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to our master strategy. We need to learn how to decode the command words and apply a structured framework to absolutely everything we write down. A truly strong understanding of computer science always begins with identifying the practical consequence a concept has for a user, a system, or an organization. So, before we get bogged down in definitions, ask yourself, what actual problem does hexadecimal solve in the real world? Before we introduce any complex terminology, just imagine a programmer. They are staring at a massive screen filled with binary code, just thousands and thousands of ones and zeros. It is completely unreadable to the human eye. If you try to copy that down, it is incredibly easy to make a mistake, right? Hexadecimal was literally created to solve this human problem of readability. It compresses long, confusing binary strings into shorter, much more manageable values. It drastically reduces human errors when copying or tracing data. When you understand this very practical, real-world consequence, you aren't just blindly memorizing a definition anymore. You truly understand its purpose. And let me tell you, that depth of understanding is exactly what examiners are desperately looking for.
Notice how this knowledge starts to build on itself. Hexadecimal representation doesn't exist in a vacuum. It is part of a much larger, connected web of ideas. To navigate this web, you need to confidently distinguish between similar-sounding terms, and you need to focus heavily on the specific device and data types mentioned in the exam prompt. This is exactly where our strategy of command word decoding comes into play. You have to ask yourself, does the exam say state, does it say describe, or does it say explain? These aren't just interchangeable words. State means you simply give a concise fact. Describe means you write out what something looks like or what sequence of events happens. But explain? Explain means you have to give the underlying reasons why or how it happens. Knowing the strict boundaries of these command words is the ultimate defense. It prevents those avoidable rushing mistakes that our friend Sam made. When you take the time to read the precise exam demand, you completely avoid the trap of answering a question that was never actually asked.
Section 2, Concept Compression. This brings us to a genuinely brilliant framework from our source material called the 3 layers of concept compression. Let me tell you, this is exactly how top-tier students structure their computer science answers, and it is going to completely revolutionize how you approach your revision from this day forward. Concept compression requires you to consciously walk your brain through a layered journey of understanding. Let's break it down. Layer 1 is the simple explanation. This is where you explain the concept in everyday language, like you're just telling a friend that hexadecimal makes long, scary numbers shorter and easier to read. That's a great start. Then we step up to Layer 2, the technical explanation. This is where we inject our formal subject vocabulary. We start stating things like 4 bits of binary equate to exactly 1 hexadecimal digit. But Layer 3 is the ultimate goal. This is the exam explanation. This is where you have to shape that raw technical knowledge into a perfectly structured, time-pressured, high-scoring response. You know, students usually think they've mastered a topic when they reach Layer 2, but they completely fall apart when forced to express it in the rigorous format of Layer 3. To reach Layer 3 consistently, you absolutely need to use the PEEL framework. That stands for Point, Evidence, Explanation, and Link. Seriously, burn that framework into your memory. PEEL. Point, Evidence, Explanation, Link. Keep that locked in your mind because we are going to use it very shortly to completely rescue Alex and Sam's disastrous answers.
Section 3. Description versus explanation. This is an absolutely crucial exam action. To successfully achieve that 3rd layer of mastery we just talked about, we have to draw a hard, uncompromising line between 2 completely different actions on your exam. Describing something versus explaining it. And make no mistake, examiners will actively test your ability to know the difference between the 2.
Let's look closely at the fundamental difference here. On one side, we have description. This is exactly the trap Alex falls into. A description merely tells us what the device or process is. It's safe, sure, but it is incredibly shallow. On the other side, we have explanation. An explanation goes much deeper. It tells us exactly how it works and why it matters in the specific scenario you've been given. Now watch what happens as we transform Alex's deeply flawed answer. We are turning those red pen marks into green check marks right before your eyes. Why is this suddenly scoring full marks? Because instead of just dropping a fact and saying hexadecimal is base 16, which is a mere description, we are shifting to a full explanation using our PEL framework. Listen to this rewritten answer. Hexadecimal is used for MAC addresses, that's our point, because it compresses 48-bit binary numbers into 12 characters, that's our evidence, making it much easier for network technicians to read and configure without making human errors, that's our explanation, thus significantly improving network setup efficiency. And there is our link, Point, Evidence, Explanation, Link. That right there is how you construct a top mark answer.
And applying that framework requires you to recognize strict theoretical boundaries. Let's flash through a few of these critical concepts. You have to know the difference between memory versus storage, validation versus verification, physical security versus logical security. Being able to recognize these contrasts quickly and accurately is what elevates your computer science reasoning from average to absolutely elite. Think about it. If an exam question asks you about memory and you start writing an essay about long-term storage drives, you are going to score a 0, no matter how beautifully written it is. You must know exactly which side of the boundary you are on. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at @AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4. The Rapid Method Review. Look, when you are sitting in that exam hall and the clock is ticking down, panic is your absolute worst enemy. You can't just wing it. You need a disciplined, repeatable strategy. You need to operate within a time management matrix, which brings us perfectly to the Rapid Method Review.
This four-step sequence is your ultimate weapon to produce structured, crystal-clear answers, completely avoiding the trap of listing random facts like Alex does. Let's break it down. Step 1. Identify the demand. What is the specific command word telling you to do? Step 2. Classify the concept. Is this question testing data representation, network security, or hardware architecture? Lock that in. Step 3. Explain the sequence. Walk the examiner through the process in a logical step-by-step order. Don't jump around. And finally, Step 4. Connect to context. Always link your answer back to the real-world scenario provided in the prompt. If you follow this four-step sequence, it practically forces you to hit the Peel framework every single time you put pen to paper. All right, it's time for our interactive workshop. I want you to mentally engage with this complex computer science data source we're looking at. Imagine a 60-second visual countdown timer ticking away right now. For Challenge 1, Data Scan, I want you to diagnose the exact type of thinking required by the prompt. Look at the options. Is the question asking you for a step-by-step process explanation? Is it asking you to justify a hardware or software selection? Is it testing a raw binary conversion skill, logic reasoning, or maybe a security judgment? Once you successfully diagnose the specific type of thinking the question is demanding, your written answer immediately becomes laser-focused and incredibly economical. You stop wasting time. The timer's ticking down. If the question is about configuring MAC addresses, you should instantly know you are combining binary and hexadecimal conversion skills with hardware identification. Boom. Time's up. Diagnosing the question correctly is literally half the battle won.
Section 5. Real-world context and transfer. If you want your knowledge to survive the immense, crushing pressure of a real exam, we have to convert your rote memory into practical usefulness. We have to leave the abstract textbook definitions behind and step out into reality.
So, let's jump into Challenge 2. This is all about finding the flaw. Consider this list of where we see hexadecimal in the wild. HTML color codes on the websites you visit every day. Error codes in complex automated systems. MAC addresses in networking hardware. Now, I'm going to read a flawed sample paragraph written by Sam, and I want you to see if you can spot the exact sentence that is bleeding marks. Sam writes, HTML uses hexadecimal for colors. It makes the code shorter. Hexadecimal is faster for the computer to process than binary. Okay, did you catch the massive flaw in that logic? Let me tell you, the examiner commentary on this would be absolutely brutal. Here's the reality. Hexadecimal is not faster for the computer to process, period. Computers only understand binary, ones and zeros. Hexadecimal is strictly 100% for human readability. If you repeatedly connect the theory to familiar, everyday technology, it helps you remember the real reason the concept exists, not just the label you memorized.
And Sam's mistake brilliantly illustrates our next golden rule, encapsulated perfectly in this quote. Generic responses rarely gain full marks. Listen to me carefully. If an exam question is set in a specific scenario, let's say a school database or an automated retail environment, your answer must rigidly stay inside that specific context if you want to score the points. Let's test this with Challenge 3, speed writing. Imagine a 30-second timer counting down right now. I want you to mentally draft one perfect Peel paragraph explaining why a retail environment uses hexadecimal for their device MAC addresses. Go. Think about it. You should be formulating sentences about the specific retail technicians, the ease of tracking physical hardware inventory in the store, and reducing human error during their network setup. If you just thought to yourself, well, it makes numbers shorter, you are giving a generic response and you will lose the mark. Time's up. Never forget, context is king in Cambridge exams.
Section 6, the 4-question self-check. This is our final exam prep. We are entering the final phase of our explainer today. Think about how far we've come. We've decoded the command words, we've applied the powerful Peel framework, and we've optimized our time management matrix. Let's wrap all of this up with a critical error awareness checklist and the ultimate self-check system you must use before you ever hand in your paper. As our master progress bar finally reaches 100%, let's rapidly run through these common pitfalls you absolutely must avoid. Number 1, vague wording. You must banish phrases like "it's easier" or "it's faster" from your vocabulary, unless you explicitly state who it's easier for and exactly why. Number 2, missing steps in a sequential process. Don't skip from step A to step D. Number 3, stating an advantage with no underlying reason. And number 4, our biggest repeat offender, completely ignoring the given context. Let me give you a pro tip. Error-aware revision notes, notes where you specifically write down why an answer is wrong, are infinitely more valuable than notes containing only correct facts. Knowing exactly how and why students like Alex and Sam fail is the secret to ensuring you succeed.
Now, what's really fascinating here is the underlying structure of process-based answers. Look at the comparison. On one side, explain the mechanism first, then state the consequence. On the other side, state the consequence first, then try to explain the mechanism. I can tell you definitively right now, for any process-based topic in computer science, ordering your steps logically by explaining the mechanism first is always, without question, the superior structural choice. Tell the examiner exactly how hexadecimal compresses 4 bits of binary into one single character, and then explain the real-world consequence of that compression for the frustrated network engineer trying to type it in. The sequence of your logic matters immensely to the examiner.
So, here is your ultimate cheat sheet recap. If you want to guarantee top marks, you need to follow the 3 rules we built today. Rule 1, command word decoding. Rule 2, strict PL framework application. And Rule 3, the time management matrix using our rapid method review. And you can test if you're ready with these 4 self-check questions. What is it? How does it work? Where is it used? And why is it better or worse than an alternative in that specific situation? If you can answer these 4 questions aloud confidently for any syllabus topic, your knowledge is officially ready for examination use. Now listen carefully. Students who implement these specific computer science strategies see an average improvement of 2 entire grade boundaries. But that only happens if you practice consistently with our weekly explainers. So here is your final reminder. Subscribe to our YouTube channel Ace the Exams, at @AceTheExams_IGCS to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCS and click that bell. Don't let another exam pass you by. And before you go, drop a comment below with your target grade for computer science and tell us the absolute biggest challenge you're currently facing. Our expert team responds to every single comment. Like and share this explainer with a study partner who needs to hear this. Ace the Exams. Your Cambridge success starts here.
But before I completely sign off, I want to leave you with one final provocative challenge to chew on. Consider the question I'm posing to you right now. Can you explain the core mechanism of hexadecimal representation entirely without relying on the exact wording you memorized from the textbook? I challenge you to strip away the surface features, put away those safety net flashcards, and really test if your true underlying understanding of the concept would actually survive the intense pressure of the exam hall. Think about it. See you next time.